Hi, my piece of the project was centered around Gay-Lussac's law. Today, I will be explaining and performing an experiment to show this gas law in action, and will tie in what I explain about that experiment into some history of this gas law, as well as to what it tells us about how gases behave. So first, let's look at the experiment. My goal in this is to show the direct relationship between the Kelvin temperature and pressure of a gas. The materials I used included a tea candle, water, a glass, a see-through dish, mine was made out of glass as well, a fork for stirring, a lighter, and red food coloring. So first, I put the water into the dish and mixed it with the red dye using a fork. Next, I put the candle into the dish, making sure to keep the wick as dry as possible, and then I lit the candle and placed the glass on top of it. As you can see, the glass will start to get foggy and the flame will be extinguished. Then the water food dye solution levels increase in the glass. The end result is that the solution in the glass will be at a higher level than the solution in the dish. So why did this happen? Fire is a source of heat, so when I covered the candle with the glass, the air molecules inside began to heat up quite rapidly, which is because they were in an enclosed space. There wasn't an excess of free-flowing air around. As the air molecules heated up, they gained energy, which made them want to get away from each other. The enclosed space limited how much they were able to do this, so the molecules began to press harder and harder against the glass and the solution below. This resulted in a significant increase in air pressure, which caused the solution levels inside the glass to actually drop. We also know that the products of a combustion reaction are H2O and CO2, as well as in this case soot because there's a limited amount of oxygen. And as these were being produced, the oxygen particles in the air got pushed into an even smaller space below the wick, which meant that the candle could no longer burn. This extinguished the flame. Then everything began to cool off as the energy is no longer being actively created, which resulted in a pull between the molecules of air. The pressure inside the glass would want to be equal to the surrounding pressure. Because of this, there would be a pulling force on the sides of the glass and on the solution. This would result in the solution being pulled into the glass, thus resulting in the water levels or the solution levels of the glass being higher than those of the surrounding dish. What this shows us is that as the Kelvin temperature of a gas increases, so does its pressure and vice versa. When the gas particles got heated up, the gas wanted to expand, which meant that the pressure of the air inside the gas increased. This proves that there is a direct relationship between the Kelvin temperature and pressure of a gas. Now let's dive into the history of this law. Gay-Lussac was in love with hot air balloons. He grew up during the French Revolution and his dad got put into prison. He was a professor of chemistry and physics, but let's put my love for fun facts about old dead guys aside to look at what led to Lussac's discovery. Lussac was obsessed with understanding gases. Like I already said, he loved hot air balloons, probably because they were a useful tool in his examination of gases around him. He used traveling through the air to help him take samples at different altitudes and in different areas to allow him to chemically analyze the various impacts of different factors on various properties of gases. He was also known for his studies of combining volumes. In 1808, Lussac released his law that basically shows us the Kelvin temperature and pressure of a gas are directly proportional. So today I provided a practical explanation of Gay-Lussac's gas law, shown and explained an experiment based on that law, described the history behind the development of the law, and I even added in some unnecessary details about Gay-Lussac's personal life. Thanks for listening.